Process scheduling in operating system. To start with this tutorial, I will introduce you first to what is an operating system, process, and process scheduling. An operating system, OS, acts as the bridge between computer hardware and users, facilitating interactions between applications and devices. It manages crucial functions like memory, files, and processes. Given the OS's responsibility for handling multiple tasks simultaneously, efficient scheduling algorithms become essential. These algorithms guide the OS in prioritizing processes, optimizing CPU usage, and ensuring seamless resource utilization. This tutorial comprehensively covers scheduling in OS, delving into its fundamentals, significance, and its role in achieving optimal CPU utilization. It further explores various methods and types of scheduling in OS. What is a process in programming? In programming, a process is an actively executing program. Programs remain dormant until the CPU initiates their instructions. In essence, a process represents a program in execution. This raises the question of determining the sequence and timing of program executions. The answer, as anticipated, lies with the process scheduler. What is process scheduling in operating system? Process scheduling involves determining the order and timing of process execution, guided by a specific strategy or algorithm. The process manager conducts this task, temporarily removing an active process from the CPU and selecting another from the queue. Scheduling in the OS becomes essential due to the multi-programming nature of most applications, allowing multiple processes to be loaded and shared with the CPU simultaneously. The process manager must make decisions on the prioritization and sequence of these processes. There are three primary types of process schedulers. Long-term job scheduler, also known as the job scheduler, selects processes from the pool and loads them into memory for execution. Medium-term scheduler is responsible for swapping out processes from memory and bringing them back in later. CPU or short-term scheduler selects a process from the ready queue and allocates the CPU to it. In addition to these schedulers, process queues play a crucial role in organizing programs and processes within the system. Job queue. Programs await execution in this queue. Ready queue. Programs ready for execution are temporarily housed here before being selected. Device queue. Processes that are currently blocked due to input-output device constraints are placed in this queue. The importance of process. Scheduling in operating systems. As previously mentioned, the operating system, OS, maintains a queue of numerous programs awaiting execution at any given moment. The OS orchestrates the initiation, suspension, and transition between these programs to ensure seamless operation. A process scheduler becomes imperative in guiding the OS on which program to execute, when to pause, and when to switch to another. Through scheduling, the OS efficiently allocates CPU time to each process based on a predefined strategy or algorithm. This approach ensures continuous CPU engagement, optimizing the utilization of resources and minimizing idle periods. The result is a reduction in time wastage, ensuring minimal waiting time for program execution. Process scheduling plays a vital role in minimizing the turnaround time for process completion, contributing to overall system efficiency. Additionally, it has a positive impact on reducing response times for programs, enhancing the overall responsiveness of the system. CPU or short-term scheduling algorithm. Having explored the foundational concepts, let's delve into the definition of a scheduling algorithm. In an operating system, a scheduling algorithm is the mechanism that determines the allocation of CPU time to specific processes and dictates when such allocations should occur. These algorithms generally fall into two categories. Non-preemptive scheduling is a scheduling strategy in operating systems where once a process starts its execution, it continues until it completes or enters a waiting state voluntarily. In non-preemptive scheduling, the operating system does not forcefully interrupt a running process to start or resume another process. In preemptive scheduling, the operating system has the capability to forcefully pause a running process, save its state, and transfer control to another process according to a predefined scheduling algorithm. CPU scheduling algorithms are used to maximize CPU utilization, maximize throughput, i.e., number of processes to complete execution per unit time, minimize wait, turnaround, and response time. There are many types of CPU scheduling algorithms. I will discuss the most important and used ones in this tutorial.